Hello everyone, welcome to our class. Today let's talk about how we actually use a pipe to communicate with some process not in the process family, not in the process hierarchy. So you want to communicate some process, maybe the process is the command line stuff, like managed by your shell. For example, you want to get what's the file data information listed in current directory. You can use ls. When you type ls on your shell, the shell will like use the process ls to like execute to run the command, right? So it can give you some result. If we want to get this result, we definitely need to like make the ls talk to our process. How we actually like communicate with the process, like not in the hierarchy, not in the process hierarchy itself, but with some like process, it's out of your process, you out of your control. This process can only be managed by your shell, your kernel. Okay, so today we will talk about popen. Popen is the one function we can use to do this. So let's look at what the popen is. Popen is a function, and for this function, actually, we can use a popen and pclose to deal with this function. When we do a popen, it's return a file pointer. So you can imagine that it's a like send.file. You return file pointers, and at the end, you need to close these file pointers. Okay, so this is the idea use of popen. But what's popen actually do? What's popen actually do? So actually, you can imagine if you have a popen, you just try to talk to the shell. So you have a shell here. If you try to do a popen, the first argument is command, which means you will send the command to the shell. So this is your process. If you have a popen in this process, if you have a popen in this process, you send out the command to shell. And based on the mode, your shell will make a decision how to generate a pipe. So actually the shell will generate a pipe here. So the shell, when shell receive this command, it's generate a pipe and try to run this command. So it will based on the command run some program. Okay, so it generate a pipe, it generates a new process based on a command, process based on a command. Then use this pipe, try to communicate to your process. So if your mode is read, which means you want to read the data from this. In this case, the shell will guarantee the process output the data to the pipe and send back the pipe to your this file stream. Okay, so if it's a write, if this is a write, then it's used another way. It will try to receive the data you like write, you like output into this file stream to the process you created by code command. So in this way, actually you can communicate to other process because this process is managed by a shell. A shell can execute, can open it to run it, this process. And also this shell, when you call popen, the shell will create this very, very important useful pipe for you to communicate to other process. Let's look at one example. In this example is a sample code for using popen. So we have a process. And in this process, you need to define the file pointers because you need to pass these file pointers here. You need to use these file pointers to get what's the file descriptors opened by this popen. Okay, so you got this. Then, of course, you need to say, I want to get the information. If you try to read, in this example, I want to execute this command. ls this the current the file information in current directory. I want to get every information output by this ls. Okay, so this is the idea. So I use a read. I use R here, means I want to read. I want to read this data. So when we run this command, What the shell do? The shell will first one will use ls because you tell the shell ls. The shell will call ls process, will generate the ls process. And also the shell will create the pipe. So this pipe direction should be like this because it's a read. Because it's a read. So the pipe will be like this. So actually, in this case, everything output from your ls will go to the input of your file. But what's the input here? The input is the file descriptor fp. So the input here is actually the fp. So that's a string, buffer string for this input. And this input will come from the output of ls. So in this case, we can use the while fgetS. We try to get the string from this. We try to get each string from this string, from this fp, these file pointers. We try to get this. Then if it's not equal to null, we just keep doing it. Then I print out each string I read. So this is the idea how you do the popen. Actually, what's the purpose for you popen? Because for regular pipe, unnamed pipe, you cannot talk to other process. You can only talk to your child process, your parent process, the process in your family, in your hierarchy. So if you want to talk to other process, for example, you have a two program, program one, program two. If you have program two, how you actually run the program two and communicate with it. You can execute some command here, like / program two. Then you can open another program. Now, of course, if this program has some message out, you can use R here to read the message. So actually, with the popen, you use the powerful shell to help you to manage this. And the shell will create this pipe to support you to receive or to support you to write, send the message. If you want to send a message to the process you just want the shell to create for you, you can also change this to write, then you can send a message out. You can receive from a pipe, you can write to a pipe, but remember one direction. Pipe should be unidirection here. Okay, so one direction defines you want to read or write, and from which process or to which process you need to give the command. I want the shell execute this command to generate another process that I can communicate to this process. So actually, shell create this pipe, also create this new process to support this popen. So this is how popen works in your program. So this is for today. Today we talk about popens, these functions. The function is interesting and useful because it's use a pipe. You already know what the pipe is. It's use a pipe to communicate to other process. But which process? You can ask your shell to create another process you want to communicate with. Then you use a pipe to communicate with this process. This is very useful if you want to get some important information from the system. Sometimes it's hard to access to this secret data because it's be protected by kernel or by other user. So in this case, you probably can use a shell, run some command, and use this pipe to receive these outputs from this command. If you want to get some information from your systems, you can use the shell to execute to trigger this process to give you this information, and use your program, use a popen to get the pipe from another process and receive this information from the pipe. So this is very useful if you want to communicate with some process you are not allowed to credit by yourself. Okay, so I hope you enjoyed today's video. This is a short video. See you next time. Popen is awesome.